The next step in pre-processing is to standardize the text. This means making the text more uniform so that different forms of the same word don't confuse the analysis. One common way to do this is through stemming, where words are reduced to their base form. For example, words like connecting or connected will be reduced to the base form connect. Stemming works by chopping off endings or suffixes from words. The downside is that sometimes the result isn't a proper word or doesn't look meaningful. For instance, studies might be stemmed to something like stud. We standardize the text this way because it reduces the number of unique words in our dataset. Using fewer unique words reduces complexity and keeps the dataset smaller and easier to manage. By removing this extra noise, we make the data cleaner and simpler to process, which is an essential step in preparing it properly for machine learning. Okay, let's see how that works in practice. First, we'll import the porter stemmer from the NLTK package by typing from nltk.stem import porter stemmer. The porter stemmer is a classic rule-based algorithm that reduces English words to a simpler base. Next, we need a tool to handle stemming. We can achieve this by creating a porter stemmer object. Here's how we do it. We make a variable called PS and set it equal to a new porter stemmer object by writing open parenthesis, close parenthesis. This line creates a stemmer object and stores it inside the variable PS. From now on, whenever we want to stem a word, we'll use PS. Let's try it out with some example words. We'll start with a list of tokens based on the word connect, connecting, connected, connectivity, connect, and connects. Next, we loop through each token and run the stemmer on it. To do that, we use our PS variable. That's the stemmer object we created earlier. So for each token T in connect tokens, we print the token, followed by a colon, and then the stemmed version of that token using ps.stem. In other words, the code takes each word, stems it, and prints both the original word and its stem side by side. See? Let's try again with some different tokens. This time, we'll use words around the word learn. So our tokens will be learned, learning, learn, learns, learner, and learners. We can reuse the same code from above and replace our connect tokens with our learn tokens. We see here that the first few tokens, learned, learning, learn, and learns, have been stemmed to the word learn, whereas learner and learners have been stemmed to their base word of learner. Now, let's try one more example, but this time with the tokens likes, better, and worse. As you see, these words are very different from one another. When we print out the results, you'll notice that some words are reduced to stems that are not real words. For instance, worse is stemmed to wers, without an E on the end. This highlights one of the limitations of stemming. While it's fast and helpful for grouping related words, it has its drawbacks. The output isn't always meaningful.